Hi, everybody. I'm going to do our notes a little bit different today. This is the last assignment I'm going to be giving you, and we're really just exploring the sine and cosine graphs. I'm taking this video on Wednesday, so that's like May 27th. You'll watch this next week, and then you have a week to turn it in. And the last day for my B-Day classes is that Wednesday, which is our last day of school. So don't worry, I'll have a great video telling you goodbye. And I just get really sad that this is how this ended. But you know what? I'm going to put my positive spirit and spin on this. So the last thing we're going to talk about are the sine and cosine graphs. I'm not going to do my normal notes because it's just a lot easier for me to show you on this graph right here. Okay, so the first thing that you're going to do, I may make one short video about like graphing by hand, but I may also just let you kind of do it. So first off, I want to show you, these are the notes that I'm doing right now. I'm going to do everything in red. And so first off, let's talk about our parent equation for sine and for cosine, okay? So if I want to have the parent equation for sine, it is literally just going to be y, can't stand when I capitalize, equals sine x, okay? You can also write f of x equals, because it is a function, it passes the vertical line test, but I'm just going to write y equals. So same here, y equals cosine x. I'm just going to write cos. Okay, let's just take a look and see what those parent graphs look like. And I'm also going to show you, I'm going to have you kind of investigate this on your own using Desmos. So I'm going to show you how you copy and paste it in this video as well. So let's look at what we're doing right here. I just signed in, I went to desmos.com. What's really nice about this is I just use my PPS account and it works really great. You can save all of your graphs here, you can share it, you can do all sorts of things. So the first one I'm going to type in is sine x. Okay, this is a sine graph. When I'm talking about graphs, I want to talk about doing like one. Sorry, I'm going to move myself over here. I want to talk about doing one cycle, and we'll talk about what that means in a second here. I always start at 0, 0, and I kind of go. I notice that it takes. This is what one cycle is, and a cycle is just how long does it take to get back to the beginning. Furthermore, that cycle is how it's crossing, pardon me, how it's going around the unit circle. Now, right now, it looks like I'm in radians, and I really just want to stay in degrees because that's something that makes sense to me. I know I'm in radians because it says 2 pi right here. So I'm going to go over here to my settings. And first off, what I'm going to do is I'm going to change it to degrees. And then I'm going to have, notice it looks really strange because I want it to not go in that like from 1 to 0 to 1. If I think about my unit circle, I'm going to kind of change my x-axis to go from negative 360 to positive 360. And I'm going to make my step, that's how much it's going by. I'm going to just make it go by 45 degrees. And those values should correspond to what my unit circle says. Let's do 45 degrees. Okay? And I'm off. Ah, that looks so much better. And what I want to do is I'm looking here and I've got these 5 key points. I'm going to ask you to do some graphing by hand, and I'm just going to take my 5 key points. I'm going to make sure that whatever I'm doing on Desmos looks the same on the piece of paper. You could also make this on your own. But I'm looking at my sine graph, and 0, 0 is a point, 91, which when I'm looking at my unit circle, the sine of 90 is 1. So that's where that relationship is. I'd go here to 180, 0, 0, 270, negative 1, and back to 360, 0. That's one cycle. Now, I do like to add one after it and one before it, but a whole cycle, these are those 5 points. So I'm going to put this in my notes. So I'm going to go right here, and I'm going to go to Share Graph, and I'm just going to export the image, and then I'm going to move myself here. And it's fine if it looks just like this. I personally, I can right click and I can copy the image. I can also do Shift Window key S. That's just a screenshot. If you have a Mac, I have no idea what to tell you. But I'm going to right click this and let's see if that works. Put it in here and I'm going to do Control V. Oh, yep, it did it in there. It's way too big, so I'm going to, obviously make it smaller. But wow, that looks really, really great. Okay. And I'll make a copy of this right here. So that's the sine one. And I really like how it kind of goes like this. And I know it's what one cycle looks like. Let's do the same thing for the cosine and see what that graph looks like. Okay? Ah, so what I notice about cosine is it looks really similar, but it's shifted. You could either say it's shifted 90 degrees to the left or it's shifted 90 degrees to the right. We're not going to talk about horizontal shifts in Algebra 3, 4, but you will talk about horizontal shifts in pre-calc. But let's see what one cycle is. Cosine of 0 is 1. Awesome. That is exactly what I see on my unit circle. I know that because I remember just going to the right on my unit circle when I was doing like the x and y axes. I got cosine of 90, cosine 180, cosine 270, cosine 360. I'm back at that same spot. So this is what the parent graph looks like for cosine. So that's not where I wanted to go. Oops, I'm gonna undo what I just did, sorry. And I'm gonna share it. I'm gonna export my image and definitely don't want myself in there. I'm gonna copy it. I'm gonna put it back in here and it's gonna go real large, but you know what? I already know what to do because I'm gonna make it nice and small. And awesome, looks really good. Perfect. And I see distinct differences between them. Okay. So now what I want to do is I want to talk about what do the transformed equations look like. We have talked this whole unit, or excuse me, this whole school year, starting in October when we did our transformations. We have a parent graph. What happens when I transform it? Left, right, up, down. When I stretch it and I compress it. Those are the things that I'm looking for. Okay. We're not going to do the left, right, but we are going to talk about the stretching and the compression. And we're going to talk about what happens to like the stretching compression. It's a couple different things here. So let's look at this. I'm going to go back here and I'm going to look first at the sine one. This is the transformed equation right here. So I'm going to actually copy this for you and I'm going to put it in there. And wow, that did not help me at all, right? But I can just get rid of that. I'll again do it in. Okay, there we go. Highlight that in red and I'm going to make it a little bit bigger so you can kind of see it. There we go. Awesome. Okay. I don't like this here, so I'm going to, there we go. Can't see how it does that. Okay. We again are not going to talk about the H part. So what I'm going to do is I'm going to show you on here, but I'm going to get rid of this. And instead, I'm going to put a B value in front of it. And I'll show you what that means in just a moment. Okay. That's my transformed equation for sine. I'm guessing it's going to look really similar for cosine. Okay? Now, what do those letters mean? What does the A, the B, and the K mean? Well, first off, let's look at the slider that I have here, which is pretty cool. Okay, so let's look what happens when I do A. Okay? Watch what happens, and let me move myself. When I make A bigger than 1, stretches quite high. And when I make it smaller than 1, it kind of almost flips it with those negatives. Notice that it's measuring from this right here, that line of 0. So A is called the amplitude. And what it's measuring from is from this middle line. That's K, and it's called the midline. So watch what happens. I'm going to bring this A back here. 2, 1. And then I'm going to bring K. See how it moves it up and down? It changes my midline. Now H moves it left and right. I'm going to talk about B in just a moment here. So A is called my amplitude, and amplitude is the distance from my midline to my maximum and my minimum. Okay. K is the midline. It's just the line that cuts it in half. Okay. And H is what moves it left and right. So let's start putting in some of those values right there. I actually have this in my slideshow and it looks really good. A changes the amplitude. H shifts the graph horizontally. K shifts the midline. So I'm going to actually highlight this here. And I'm going to go back here. and talk about what do those words mean, okay? So I've got amplitude. I'm going to just do this here. That's going to be a lot easier. Okay, changes the amplitude of the graph. So A is the variable we're going to use. And I'm going to put parentheses around it so we know. It changes the amplitude of the graph and it stretches or compresses it. It also, amplitude talks about it is the distance from the midline to the maximum or minimum. And it's actually the absolute value because it's the same distance from both places. The negative just flips the graph around. So when we say distance, remember that's like the absolute value. Because distance doesn't have a direction or it doesn't have like a negative or a positive. It's just how far away it is. But what happens is when we give it like a north or a south, that's what changes it. So I'm gonna make this red. Next, I'm gonna type in what the midline is. I like that definition a lot right there. It shifts the mid, so it's the value of k. And I'm gonna put that and shifts the midline of the graph. Okay. And we'll talk about period in a second. So that's really cool that it can do that stuff. Sine's the same way. Let's talk about what happens with cosine. It's the same stuff. A still changes it like that. Okay. H still shifts it left and right, and K still shifts it up and down. Okay. So those are those things. Let's talk about what happens when I change my period. And this is period. I'm going to leave both of these. Leave. And I'm going to go back here. Okay. And I'm going to go here and I'm going to kind of investigate a little bit. I told you period was my B value. So I'm going to put a value in front of here. And I'm going to put the value of 2. What happened? That's hard for me to see. So I'm going to actually do cosine of x so I can compare it. Wow, it condensed it. Okay. And so what the period does is it controls how much time it takes for one cycle to happen. You're going to notice as you play around it, numbers that are bigger in one actually condense it and it happens in a less time. Let's say that a normal period for a parent was 360 degrees. This time it would actually go half that time. And then let's see what happens when I do cosine like a fraction. So x divided by 2 stretches it out. Okay. That's because we have this really great thing. Period is equal to 2 pi over b, or it's equal to 360 over b. I'm not going to have you know those equations right now, but I'm going to show it to you real quick here. So we've got this. Okay, awesome. That's just Miss Watson's awesome PowerPoints here that I would have showed you if we were in class. So period of the function. It looks like this right here. So we put the b in front of it. These are, how does it relate to it? These are the actual like equations. So I'm going to put these down in our period thing right here. I'm going to do this here. I'll change everything so it's in red. Here. Sometimes I just gotta, there we go. Period. It controls how long it takes the function to complete one cycle. Okay. So I'm gonna take this, put it in red. Great. Okay, I think that's pretty much all that I have left for you right now. Let's look at our notes again and see if there's anything else that we want to put in here. These are just some different transformed graphs. I'm not going to put that in there, but you can obviously put that in there. Okay, so the last thing is I'm going to show you a cosine plus 5, and then I'm going to put like 3. Let's do 0.5. Okay, there we go. And I'm going to X out these. So this one right here is a cosine transformed graph. and it has moved, looks like the midline has changed to 5. That's the middle of it. And so it looks like the period has been condensed for how long it repeats itself. So this is a great example of what that would be for cosine. And I can do the same for sine. I'm not going to put it in the notes. I don't think that's really necessary. So what are you going to do today? You are going to kind of go through the same thing in a Google Doc for me, and you're going to show me how you can make the graphs, and you're going to actually try to do it by hand. If you don't have a pen or if you don't have a printer, you can obviously make this right here. I'm just putting degrees on the x-axis, and I'm putting the y values on the y. Okay? So that's what you're going to do for the classwork here, but hopefully this helps with the notes. I will make a copy of this right here, and I'm going to just get rid of those for you. And yeah, hopefully that helps. Thank you.